Hello and welcome to C++ 101, Week 7, Introduction to Object-Oriented Programming. I'm going to be here, and Gavin's going to be here.
Hello.
Hey.
Hello.
Hey.
Hello.
Hey.
Hello.
Hey. Okay, so up until this point, I've asked people to really not... like, people who already know what a class is. I've asked people to kind of avoid understanding what a class is, because some of the stuff that we've been talking about leading up to this point, I think, will lead really well into a discussion on what a class is. And hopefully people new to programming will see how the organization that we've been asking for in the homework actually does relate into an object-oriented paradigm. So let's go ahead and...
So are you saying we're allowed to remember what a class is now?
No.
If we've met one in another language? Or are we not?
Well, classes are similar enough in C++ to other languages. So, I mean, drawing on those past experiences could be helpful. That being said, there are some nuances that are important to keep in mind. So, basically, object-oriented programming is a programming paradigm, and what I mean by that is it's a way to express logic. Early on in programming, all we had were inside of assembly. All we had were subroutines, where you had functions that had parameters and return types, and you had the call stack, and all was good for a while. But people quickly ran into issues with maintainability and scalability of their applications. So, as a result, an entirely new paradigm was invented for programming, called object-oriented programming. And object-oriented programming, all that is you don't think about your program in terms of functions. And to avoid any ambiguity to the functional paradigm, I am not referring to functions as pure functions that would fit the definition of a functional paradigm. I'm referring to functions as what would typically be referred to as subroutines, where we encapsulate imperative logic into reusable chunks. So object-oriented programming, instead of doing that, what we do is we define our applications in terms of different objects and the relationships between different objects. So what's an object? An object is, you can think of it like a variable. I mean, you should represent your objects as variables. Obviously, that's the only way to express them. And they're variables that have a lot of functionality sort of built into them. They have functionality in state, or behavior in state. And objects are a runtime concept, and the communication between objects is a very great way to express so many of the problems that we run into as programmers. The object-oriented paradigm, though, funny enough, didn't actually gain traction until like 20 years ago. It's been around for a while, but it was shunned and feared by developers, and finally it's become a sort of mainstream paradigm that people have been using to express.
Why did it take so long to take hold? It seems like an eminently sensible and obvious,
it does to us,
common sense solution.
But
just the idea of reusing logic and reusing, or is that just applied laziness? I mean, it just seems fairly self-evident.
Remember,
or was it down to the programming, to the processing power that was available, the memory that
there's a lot of different considerations. Remember, though, that with imperative style or procedural programming is a style of imperative programming that uses procedures. Just like object-oriented programming is a imperative paradigm that uses objects. And when I say imperative, what I mean is the concept of an if loop and a while loop, and you're speaking to the compiler in imperative language. Again, imperative languages that's not the only paradigm in existence. Functional languages are completely different, but the reason it didn't really catch on was, if you think about it, you can express plenty of reusability in the context of procedural programming. You can always break things down.
Chuck up an example of. Can you chuck up a small example of the old-fashioned way of doing it to give us something to work from?
Well, I mean, for example, the vector that we implemented before, where we have a struct called like inventory, And inside the inventory struct, we have we need our products first. So we have a struct called product and something like that. Then inventory, which has a products array pointer and a int count. But what makes this, thinking about this procedural, is when we have these global functions such as init inventory and destroy inventory, methods like this that take in a sort of pointer to an inventory object. Now, I do want to point out really quickly, though, that this is actually a step up from pure procedural design. And when I say that, I mean a pure procedural design would typically use, instead of having a struct inventory like this, these would be global variables, and these different functions would work against the global state. This example actually is a step up from that. It's still procedural design, but we're kind of encapsulating different reusable bits of logic in terms of our inventory structure.
And just the reason I'm not forcing Nelson to go all the way back to the completely old-fashioned way of doing it is just that getting him this far is like cutting off his hands. making him write this much in this fashion. Yeah. Well,
and what people realize, though, is that this pattern became so popular, and you see it in so many C libraries, especially because C is a programming language that didn't have any object-oriented facilities. And so you see this pattern very often in well-written C code. I would consider what you see right here well-written C code. The definitions of the structures would look a bit different. Obviously, you wouldn't have a string type because that's a C++ thing. But the point is this would be considered well-written C code, well-organized C code.
The architecture would be.
Right. And what object-oriented programming sort of came to the realization too is that this pattern is so common. Why don't we codify this pattern into the language itself? Why don't we bake facilities into the language itself that allows us to express these ideas in a much more succinct way? And a lot of people just didn't like that. There was a lot of people who were concerned about the performance of object-oriented programming. They didn't like, they liked, I read this great article the other day. I was talking about this guy who wants to, he doesn't want to do away with a computer science degree, but he wants to make a software development degree. And his sort of thinking during his defense of wanting to make a software development degree was that so many problems computer scientists like to think about in terms of memory and arrays and global variables, whereas business developers, people working on larger software projects, like to think in terms of things like abstractions. And this, what you see right here, is an abstraction, but it's not represented in a very clean way because the C++ programming language gives us the facilities to express this in a much nicer way. And people they didn't like OOP. They thought it was unnecessary, it was too complex and annoying. And eventually, C++ wasn't the first object-oriented language. See, I love programming history. I really love programming history. But for right now, for some reason, I cannot remember exactly what the first object-oriented language was. I really want to say it was Smalltalk.
I was wondering about that. That's the one that was used in the Gang of Four book, wasn't it?
Smalltalk? I thought C++ was.
I think they did. I thought they did them in both of those.
No, Java.
But I may be thinking of something else.
Java is late 90s. Smalltalk is 80s, I think, and C++ is 80s.
Right.
So yeah, no, C++ wasn't about, what about Scheme? Scheme's a Lisp dialect, isn't it? See, I really wish my brain was working.
What, are you saying that's how you pronounce the sound of somebody with a Lisp saying scheme, or I'm confused?
No, yeah. Scheme's a Lisp dialect. Scheme is not an object-oriented programming language. It's a functional programming language based off of Lisp. Lisp is a dynamic functional language, which means it is absolutely and utterly inherently different in every way from C++. Again,
anyway.
I really love like the programming history, but my brain isn't at full capacity this morning.
Yeah, we're straying off. It's interesting
Okay, so
stuff, but I know you could go on talking about this for years.
yeah, because this is fun stuff. But the basic point is object-oriented programming is about thinking about the crafting a program in terms of relationships between objects. And what we do is we build our programs to run at runtime and have these little entities, these little living souls within our application called objects, and they talk to each other, and we define the relationship between each other and the different behavior that they have when they relate to each other. Now,
but surely we've already got objects, have we not? I mean, we've got a product, we've got an inventory.
Sure. We have objects here, but the reason, though, I did want to. These are that when we make variables out of these things, they are considered to be objects. But I wanted to avoid that terminology up until we got into this lesson. But these are considered to be objects, but they're not the best objects. Basically, an object-oriented programming language, a language built specifically for OOP facilities, and C++ is one definitely. Java, C#, Ruby. What an object-oriented programming language isn't a language that you have to use in order to express object orientation. You can express object orientation in any language you wish. An object-oriented programming language is a programming language that gives you the inherent facilities and kind of helps you along the way to realizing an object-oriented design. And the primary way in which we do that in the majority of languages that support object-oriented facilities is via classes. And what a class is a class is a template, it's a blueprint of objects. So we might realize that our application needs a person object, and the person object needs a relationship to maybe a list of addresses because we're making an address book program. What we would do is we would define our object model in terms of a person class and an address class. Neither of those things are runtime concepts, but we use the classes to create the objects. So a class is a template that allows us to create objects with our language. So I'm going to go ahead and really quickly just take this code and turn at least this code into a class. And I hope people will be able to immediately see the difference beyond just the syntax.
Well, there was one phrase that you used in the introduction of when I said what a class is that is key here. It's got state and behavior. This is kind of what I was nodding towards when I asked about the structs.
Again, I'm not going to fill out these methods. If you want to see the definition of these methods, look to last week. The point is the difference in organization. So what we've done here is, again, it was such a common pattern that we would define our state as a structure, because C had structures, and in C you could put any amount of data that you want into structures. They represented a bit of state, a variable that contains more variables, and then
purely a DTO, a data
purely.
Transmission object.
Nothing more, because in C you couldn't put functions inside of structures. You could only put members or fields. Sorry. And then we would define behavior in terms of these global functions, typically passing in a pointer to our state as the first parameter to every one of the functions that we define. Again, such a common pattern. Would
that be the root of the main args that you pass into main in various languages?
No, that's for command line stuff, or am I getting confused?
No, I'm probably getting confused. Carry on.
What we've done here is this could may look a little funky, but we have basically took the concept of what we have right here between lines 30 and 38, and we've represented it using a C++ facility of classes. So you'll notice here on line 13 and 14 we have our state. We have two fields. Classes may have fields just as structure may have fields. And you'll notice something.
Is your indentation?
This is correct.
Is that? Yeah, that's annoying.
We're going to be talking about accessibility later, but for people who might be looking at this code coming from other languages, you should know that in C++, accessibility is defined in terms of blocks. So this defines a public block accessibility. Every member from this to either the end of the class or the next accessibility block is public. Classes by default are private, meaning that this would be redundant to do. This would declare both these fields as private, but that's redundant because classes are by default private.
Would you, what about using the private modifier outside, or have we not got to that yet?
No, there's no accessibility on types themselves.
So, right, okay. So you can't put private class on line 11.
There is accessibility in regards to inheritance, which is weird. You can privately inherit something. Shows that.
Okay, let's not get into that.
Strange concept, but C++ is full of these weird little things. So people coming from Java or C# may look at this and say, ooh, what's going on? Well, again, all of these members are public, all of these members are private. And that's all you got to know. You do not have to annotate each member with the accessibility modifier.
And would you, is it even allowable if you wanted to wrap your public, you know, all of your similarly accessible things in block notation? Is that allowable?
I don't know if it's allowable, but I've never seen it done. I think it would look ugly.
Fine.
I've never seen that done before. I mean, I doubt it's allowable, but we can try just for you, Gavin. Yeah, it's not going to do it.
Okay.
Alrighty. Why use underscore on variable names? I'll get into that once we start talking a little bit more about accessibility. You still need the semicolon. You very much do still need the semicolon. Structures and classes and enums all follow the same sort of declaration archetype, I guess you could say, in that they all are going to be a keyword followed by identifier, followed by a block, followed by a semicolon, which means that you can create unnamed classes if you want, as well as you can create objects of a class immediately by placing an identifier after the curly but before the semi. What's the tilde for? We'll look at that in a second, actually. Because what I'm going to do is I'm going to show instantly why classes are better.
Too slow.
Well, did I say instantly?
That wasn't instantaneous. Yeah, that wasn't even remotely instantaneous. There's definitely typing occurring at some point. Wolf Knightley, I'm totally with you there. He said, things that aren't C# scare me. NATO, all the same principles apply as with C# classes, but it's just syntactically slightly different. But I mean, conceptually the same things apply.
Okay, so let's first work with our C-style inventory API.
Could you actually put the old-fashioned, the C-style one in a separate CPP file?
It'll take too long. Okay, before I go any further, does everybody understand where the ampersand is? Does everybody understand what this code is doing right here? It should look very familiar to what we did last week. Is everybody good with this so far? Again, this is just a review thing, but I just want to make sure if there's any questions about how this code works, then you're going to be hung up on the rest of what I'm about to show, so then we might as well address that now. Okay, so this code is going to be very straightforward. All it's going to do is it's just going to print out what we do to the inventory. So it's going to say function init inventory, function add product product 1, function destroy inventory. So this code already represents the logic of what we want to express, but it's very ugly. So let's see how classes make this better.
Well, there is one thing in there, actually, which is destroy inventory, line 64.
Mm-hmm.
You haven't really ever talked about.
Yeah, in this case, this would delete the, so you don't get a memory leak, it would delete the dynamically allocated array.
Makes sense. What with the name and everything. But I just thought I should bring that up.
Oh, come on. What did I call this?
Gerald.
No, my stupid IntelliSense is broke.
You should pay it more. Oh, yes.
Oh, right. Derp. Actually, just to be consistent. I do really quickly want to point out that the destroy inventory from the class actually does get invoked, but you might not be able to see it because it's going to happen immediately after the get. So I want to point out that although it's not being represented there, I can prove it to you by putting a breakpoint right there and run this code and hit enter. Notice this code does indeed get invoked. This code takes advantage of a class. What we do is we first create a variable of this type. We create a variable called new inventory of type inventory. And we kind of create our little product that we're going to add to it. You know, we can get this from a file or from user input or hard coded or whatever. And then we say new inventory.add product p2. Notice how I'm using the member access syntax to access this function. In fact, the great thing about doing OOP this way is that discoverability is very important, where you can just hit dot and you can see a variety of different members within that type that you can take advantage of. Very similar to what we've been doing with strings and vectors so far.
They've got lots of pretty pictures decorating them as well. It's just that, so is that some sort of pony theme, or does it have a wider purpose?
Oh, right. There's different, you know, the purple is going to be methods, the blue is going to be fields, the little lock icon is going to indicate private accessibility, and so on.
Cool.
But yeah, so what we have here is a very interesting bit of code where we have multiple things happening implicitly. Because the C++ compiler takes advantage of a lot of, well, it doesn't take advantage of, but it provides us a lot of shortcuts to doing things we would have to do manually before. Notice the second I declared, or the second the compiler reached line 98, line 19 got invoked. This is called a constructor. Notice then on line 71, add product gets invoked. This is called a method. And then notice when main terminates, or immediately prior to main terminating, line 24 got invoked. This is called the destructor.
And that's what the...
That's what the tilde means.
Well, yes. I mean, you should, first of all, how does it know which one's the constructor?
Right. By not having a tilde.
No. I mean, out of any methods that might be called Gerald or Raymo Dash or whatever, how does it pick one and say, okay, this is going to be the constructor?
Right. So basically, underneath the class, you have a variety of different members. There's two primary types of members. There's methods and there's fields. We've already talked about fields. They're very similar to struct fields. Don't really require too much discussion, although the discussion about the naming convention I use here is going to be important later on. However, right here we have methods. All of these are methods. By default, you'll typically be writing mostly methods like this. And methods like this look just like functions, except for they're encased by the curly braces of the class definition. So you'll notice it has a return type, it has a name, it has a parameter list, and it has a body. So it follows the exact same syntax as a normal global function, except for it's called a member function. And then
I just wanted to ask, because I've always thought of it as being the definition of a method is a function inside of a class.
Yes.
Yeah.
So a method is going to be a function inside of a class. And each one of these things are methods, and they will behave the exact same way as methods do. They're just definitions and do not do anything until they're invoked. However, these are two special methods. We know they're special because not only do they lack a return type, their name is also going to be the same name as the enclosing class. When you have an undecorated identifier, that's the same identifier as the class and has no return types, it's called the constructor. You can have many constructors as you want. In fact, you can have many different types of constructors. Unlike C#, where you may only have one kind of type of constructor, in C++ you get copy constructors and move constructors as well, which get into...
Copying and moving.
Yeah, it gets complicated. But this is just the main form of constructor that most people would be familiar with if they know another object-oriented language. This is the destructor. Well, first, what a constructor is. A constructor is code that will be executed every time an object of a particular type is created. So whenever you either...
And that's the first thing that happens when it's created.
Yes.
That's the equivalent of main, but for a particular class.
So whenever, like, for example, on line 68, the inventory constructor gets invoked. If I were to add instantiated this via the new operator, it would still get invoked. Dynamic memory allocation doesn't have any consequences in regards to constructors. And then you have the destructor.
And just to point out, because I mean we haven't really mentioned it. I suppose we did earlier, but we haven't mentioned it here. You've got to have the parentheses for methods, just like with normal global functions.
Yep. Okay, so the destructor is going to look a whole lot like a constructor, except for it's going to take no parameters, and it's going to be prefaced with a tilde.
So the constructor can take parameters?
Yes, and you may overload constructors. Destructors, however, may not take parameters, and you cannot overload them.
Makes sense. They have a specific job to do. But the on the subject of parameters in the constructor, do you always have to have one without?
No.
Okay.
You may create a class that has a constructor that doesn't have that has parameters and one that doesn't have parameters. That'll make, so for example, if I said int ble, you'll notice I get a compiler error down here saying no appropriate default constructor available. Okay, so a destructor is invoked under two conditions. Can anybody guess what the two conditions that a destructor is invoked on? Yeah, pretty well. Yeah, a lot of people got pretty close. A destructor is invoked in one of two cases. In one case, when the object that you are working with is on the stack, the destructor will be invoked when the variable falls out of scope, which is typically going to be the end of that function. So the destructor will be invoked. Also, for example, if you'll notice, I can do this. I can introduce an arbitrary scope, which will cause the destructor to be invoked on line 73. So if I run the code now, you'll notice class destroy inventory got invoked before the cin.get. Because the inventory was allocated on the stack, whenever it fell out of scope is when the C++ compiler emitted the instructions to invoke its destructor. The other instance of when a destructor will be invoked is if you dynamically allocated a type and you use the delete operator on it, on that object. The delete operator will invoke the destructor of that object. I do want to point out somebody said something about class no longer referenced. Remember, C++ does not have a garbage collector. Now, in garbage collected languages, what you have is a little like sort of manager guy who every now and then looks at all of your objects, looks at the references between each other, and tracks down objects that are no longer being referenced and removes them from memory. C++ is not like that. All memory allocation and deallocation in C++ is manual, meaning there is no other runtime component to a C++ program that is going to work with your dynamically allocated memory. And as far as an example of dynamically allocating an inventory, it would look something like this. In this case, we instantiate an inventory. The new operator will invoke the inventory's constructor. We add a product to it, and then we delete it. The delete operator will invoke the destructor of the inventory type. So that's what we get right there. Now, it's really important to understand how state is managed. Basically...
Do you want to... there are some syntactic questions that have come in while you've been talking. Do you want to just cover those before moving on to the...
Okay, are there in a certain order? No, order does matter, kind of. Order only matters in terms of what you can access in your functions. It doesn't. It's not important as far as what you can and can't do.
Sorry, I didn't quite follow that.
Order follows the same rules as like a function. You can't invoke a function if it hasn't been defined. But other than that, there's no implication of the orders of members. So
okay.
Constructors and destructors and methods and all that stuff don't
they
have
can
to
go at the end and it wouldn't matter.
Right, as long as they don't reference each other. At that point, order starts to matter.
And in actual fact, if you think about it, that makes sense given that you've got to put your public your accessibility modifiers. You want to be grouping those.
Yeah.
So you're going to be setting the order up to you're going to be putting all your publics together, all your privates together, rather than the order in which they you would ordinarily want to put them in.
Yep. Okay. Are both constructors and destructors optional? Yes, they are. You may or may not provide a constructor or destructor for a class.
Is it like, does it go behind the scenes and make one for you, or does it work the same as?
I actually don't think so. I think it just won't emit the invocation if there is no default constructor.
But what will that cause to? What will that mean to you as a programmer?
Nothing. It's important it's an important consideration with languages that have reflection, but C++ doesn't have reflection, and so it's not much of a concern. In C#, it's important that there's a constructor generated. Otherwise, your reflection code, when it's dynamically instantiating types, would become a lot more complicated. But C++, that's irrelevant.
So basically, it doesn't matter if you well, I mean, it matters, but in terms of actually compiling and running, you wouldn't need to have a constructor.
No, if you don't need it.
Okay.
So you don't need to call the destructor. No, the destructor is called automatically, depending on if you're...
Are there situations as you become more experienced where you would choose to call it yourself?
There's no way to.
Or, well, I was thinking in terms of the bracketing that you showed, the scoping there on 68 through.
Oh, actually I was wrong. You can invoke the destructor manually. Never do this. This would be an automatic fail. Because now at this point the destructor is going to be invoked twice. Yeah, that's horrible. Yeah, I'd never done this before. I'm learning new things all the time. No, that's just silly. Anyway, doing this is actually very useful in some cases where...
You can't just gloss over that. Where does it find that destroy? Where does it find that destructor if the thing doesn't even exist?
Huh?
How did it find the destructors for all? Oh, but
I specified it
no,
using the tilde syntax.
Yeah, but then it. Nah.
As far as doing the scoping thing to deterministically invoke a destructor, it's a very common pattern you'll see with as a replacement for using statements in C# for like streams and stuff like that, like the equivalent of disposing.
Okay. It's just as with all things in programming, I've come to assume that there are prolific edge cases for things. So I just was wondering what they were. But that's cool.
Is memory for your inventory allocated on the stack or the heap? That's completely now, unlike words.
In this example that you've given.
Yeah. I do want to reiterate this though really quickly for people who are coming from other languages, languages that have value types and reference types. C++ does not have value types and reference types. And what I mean by that is the type of a type doesn't determine the behavior that it has during runtime. In C#, for example, value types are passed by value, whereas reference types are passed by reference. Whether or not value types are stored in the heap is irrelevant, actually. Typically, they'll be stored in the stack, but that's an implementation detail. In C++, you have complete control over whether or not your object is instantiated on the heap or the stack, and whether or not you pass that object by value or by reference. You have that complete control for any class that you make, meaning that whether or not an object is on the heap or the stack is determined solely by how you define that object in your side of your function, and not by anything you might annotate the class itself with.
You said steep or hack. Yes, okay.
So in this case,
that being said, in this case...
This is on the stack. This is on the heap. And we know this because we're using the new operator to allocate dynamic memory.
Cool.
Can you call the destructor manually?
A couple more.
Yes. Well, we just showed that you can never invoke the destructor manually, ever. The way that a person reasons about writing classes is that destructor should only be invoked once, and after that, it shouldn't be valid anymore to access that class. The whole point of a destructor is to do things like clean up dynamic memory. So, for example, following the example that we had from last week, where we have this product pointer that points to a product array, this would have to be deleted manually at some point. And the way that you would do it is in the destructor of the inventory, which means that the product array is going to be destroyed whether or not the inventory was on the heap and deleted, or the inventory was on the stack and the function went out of scope. So the state of an object should not be considered valid after the destructor is invoked, meaning you should never invoke the destructor manually. Okay, An example, you pass product by value, not reference. Is there any reason for this? Why would you normally pass pointers to methods for better performance? Typically I would. Actually, I wouldn't. I would use references. Because just to throw a completely new bit of terminology from, halfway across the C++ specification, C++ supports the concept of what are called references, which are like pointers, but not really pointers. And that's what I would typically use. What?
It's not that far away. I mean, P and R, there's only Q between them. There can't be that many things in the specification that begin with Q.
I wonder if there is anything in the specification beginning with Q. I need to look that up.
Quaternion, possibly.
Nah, I don't think there's a built-in quaternion.
Anyhow.
Can methods be prototyped? Yes, they may. We'll get into that once we start talking about breaking classes up into header and CPP files. Because at that point, prototyping your methods will become very important.
Well, you know what? I think that would be a good time to take a short break, and if you have any more questions on what we've covered so far, please put them in the questions panel, and Nelson will just zip through them when we get back, and then we will carry on with the next section.
Yeah, because all we have at this point really is accessibility and header and CPP files, because...
And yeah, but the store, where the file, what the files are called, and all that stuff. I think, yeah, that's... I called the break a bit early because obviously it's going to be a shorter lesson, but it will just give people a chance to sort of cogitate and go, oh, actually.
Okay, and we're back. We did get an interesting thing. Essentially, classes are just for programmer usability. A lot of things...
Oh, I know.
This is an important discussion. A lot of things that people new to programming... Typically what happens is you learn imperative programming first. You learn about conditionals and looping and variables and arrays. And with those tools, you can express, with functions, variables, arrays, looping, and conditionals, you can express any program you wish to the compiler. There's a name for it. It's called a Turing Completeness. And you can express any logic that you wish. However, after that point, after the basics of imperative programming come into play, the next step is really important, and that's about it's really about not programming usability, because I think that has some negative connotation in my mind personally, because the use of classes isn't about usability. The use of classes is a way to design, to architect, to organize, and to express yourself. Using a completely different paradigm, and a shift from the basic procedural paradigm to the object-oriented paradigm does take time, because procedural paradigm is very straightforward to understand. I mean, I'm not saying that you knew exactly what an if statement was the second I typed out the screen. No, you still have to learn it, but it's a relatively straightforward, easy to step through process. The whole concept of object orientation is more than that. The concept of object orientation is all about abstraction. It's all about creating layers and frameworks and components and the relationships between them. It's really all about the architecture. And when you
see sorry, I didn't recognize that there was an and coming.
Well, when you what was I saying?
Sorry, I thought it sounded like you were heading towards the end of a sentence. Sorry.
Well,
I was just going to say, from my point of view on that, from learning this and getting a feel for it, it's very much like the procedural way of doing things is like a pad on each page you write one thing to do, and then you just flick through, page 1, do this, page 2, do this, page 3, do this, page 4, do this. Object orientation is just taking that and putting it into files in a filing cabinet, really. So you have the drawer marked console that deals with all the console stuff, and inside that you have a folder that deals with changing colors, and then inside that you have the necessary files that actually deal with it. It's making it into an what's it called? Like a directory structure, a hierarchy.
Right.
It's making it hierarchical rather than just everything being of the same on the same level.
Yep, and you organize your hierarchy in terms of abstraction. So you start with components that are more controllery in nature, that sort of orchestrate the communication between other components, and then those other components may rely on tertiary components and go down and down the hierarchy up until the point where the amount of code you're saving by depending on the abstractions just increases exponentially.
And actually, Affix is, yes, he says, I see it as a family tree, OOP. And yeah, exactly that sort of image. That, getting a visual like that in your head is the key way to understand this, because that is exactly what it is. At the root of everything, at the trunk of that tree is an object. Everything's an object, conceptually. Mm-hmm. He added rapidly. I could hear you gearing up to slap me down. But yes, conceptually, the root of that tree is the object, and then you've got branches that deal with progressively finer and granularity of what they deal with. So eventually, that you get down to the point where somewhere in the system is a thing that flips on or off the LED components of,
right.
Sends messages to your monitor telling it what color to display.
Yeah, and I do want to point out also, though, that while the procedural paradigm, again, it's not necessarily something super easy to learn. I mean, anybody can learn how to write code procedurally, but that's because we tend to think procedurally very easily. Once we start getting into object-oriented programming, that in my experience, as much as object orientation tries to mimic the real world, it truly is a concept and a feeling and an intuition that is developed in isolation of the real world. And I find that the whole creating properly object-oriented systems is a skill that you learn that you can't draw too many bases from the real world. And when people try to do that, they often fail. Just like when we're talking about the Liskov substitution principle, where a person might assume that a square is a rectangle because that's how it is in the real world. Well, it's not, actually. Just because it's that in the real world does not mean that's appropriate to model it that way in your program. So I just kind of wanted to throw that out there because it's a very important concept. Because when you say, "Ooh, objects are just just for programming usability," I sort of, and I'm not mocking the person who said that. That's a very valid concern that a lot of people have had, and that's.
Or at least you're not mocking him for that, at least.
Well, it's why object orientation didn't catch on until people finally started to get it. People started finally realizing that wait a second, we can be so much more productive in a purely object-oriented language, or even a more object-oriented language in C++, because we think this way. And C++ provides all the object orientation features of a typical language. Even more, it does provide a lot of weird things. There's a lot of weird stuff in C++. Like, honestly, I don't know what the guy was thinking, but the fact is that object orientation is a really important concept. Doesn't have too many analogs with the real world, although it's deceptively similar. And it's a skill that will ultimately change the way you view programming, period. Just like functional programming is another skill that will change the way you think about programming, period.
Actually, I shall bring this up because it seems to tie in and sort of round that off quite nicely. Do you know of any good online resources, he said, to read up on OOP and using it? And I would point you towards getting hold of the Gang of Four's.
Yeah, Gang of Four
book.
Great book. Domain-Driven Design by Eric Evans, I believe, is another great book. What
Design
else?
Patterns for Dummies.
Never read that.
That's there's the For Dummies series. Yellow books. I've read the Design Patterns one. It's excellent. Very, very good.
Although here's the thing, though. Like, everything that you work on as far as object-oriented design, it really depends on the situation. I've built quite a few different architectures for games and applications, and each application and game typically has different requirements. And creating and knowing what things go where and what's appropriate for one solution that may not be appropriate for another solution is very important. One of the things that I find very helpful is to find a person who does a blog that you like. Identify what it is, what kind of programming you want to do. Do you want to write business software? Do you want to write web applications? Do you want to write desktop applications? Do you want to write video games? Do you want to write game engines? Pick an industry or a few industries and follow blogs of people who are in that industry, because those people, typically what I find, especially in the web development industry, how I really got into object orientation, because I was first hired professionally as a web developer, so obviously my that's a little bit, biased towards web development, but it's very common to see, high-profile web development consultants go out and talk about the designs of their architecture, not just how they came up with things, but pitfalls, issues, or even how things went great. And reading about that gives you a nice perspective, but there's nothing that's going to replace just doing it. And the extent of which you know that your code is properly architected is typically measured by how much friction you continue to have after a few months of development. There's quite a few projects that I've put together that have been in place for years, and every time I go to maintain them, I get a really good feeling because everything has a place. I've completely forgot everything about the code base. But because everything follows a structure, identifying where things should go is relatively straightforward, and that's what good object orientation is going to lend you towards. And I've also looked at systems I wrote in a very procedural and very naive way, and vomited every time I had to make an update to it, because I completely, not only did I forget where everything went, I couldn't find it out.
Yeah.
Okay, so questions. If you have a pointer to an object on the heap and you delete that object, using the statement delete my object, does the memory allocated to the pointer automatically get reclaimed? Or do we need to do something to free it up? The delete operator will immediately reclaim any memory. As in line 77, will completely deallocate whatever it is that other inventory is pointing to. Now, it doesn't deallocate the pointer itself. You can't deallocate the pointer because the pointer's on the stack. The pointer itself, the variable named other inventory, is on the stack and may not be reclaimed until the function exits. However, the delete keyword on line 77 will actually reach in, find wherever that pointer is pointing to, and deallocate its memory and free it up for use for other reasons. Of course, at the end of this, other inventory does indeed become a dangling pointer. As you'll notice, if I go ahead and run this program, other inventory is pointing to arbitrary memory. So typically, after deleting something, you should get in the habit of setting it to null. I mean, I haven't been doing this all that much in these cases because our dynamic memory allocation has been very straightforward. I did do it for the vector example. I did set it to null, and the reason is you really do want to indicate that this pointer is not pointing to valid memory anymore, because otherwise people might assume that it is indeed pointing to valid memory, and then they'll get a weird access violation. Instead of realizing that the pointer is null, they might think it's trying to point to a valid memory, and then they'll just get all confused and the world will end.
Or worse.
Yes.
You're welcome.
Hmm?
I said you're welcome to him on your behalf for saying thank you by him to you on his behalf.
Huh.
Did that clarify? Like butter. Cool. So what else have we got to cover?
Is there a default constructor? Not that I know of. I don't think there is, but it doesn't matter if there is or not. I'm pretty sure there isn't. I'm pretty sure if you do not...
Default destructor, but...
words are hard. No. Nope. There's not a default destructor. There's no reason for there to be a default destructor. Because the destructor is used solely for an opportunity for the object itself to reclaim the memory it has allocated. So for example, if we did something like this in our init, we said products equals new product 10 count equals 10, we'll want to make sure in our destructor to say delete products, because this allows our own classes to reclaim the memory they might have instantiated during their lifetime.
It's like a pass it forward sort of thing.
Yeah, and the relation it gets really complicated without garbage collection. Managing pointers is a very important concept in C++, and there are ways to deal with it. I believe the auto pointer was just standardized. If I'm not mistaken, it was from TR1 and got standardized. And what it is it's a wrapper around a pointer that will automatically delete itself under certain circumstances. But the use of it is a little bit beyond the scope of what I wanted to go over in this course. So no constructor and destructors having defaults. No. Well, again, actually, I'm 99.9% certain no. And the reason it doesn't matter, though, is because it just doesn't matter. It matters in C#. It very much does, because in C# you can use reflection to instantiate classes during runtime. In C++ you may not. The concept of a class in runtime in C++ is non-existent. Now, certainly there is something called runtime type information, which, meh.
But the compiler essentially turns your nice object-oriented code back into procedural code, really.
Yeah, actually, that's a good point. Something I wanted to point out is because you'll notice here that our init inventory, destroy inventory, and add product all take a pointer to a structure that contains the state. This is not in any way unlike what classes do. In fact, there is a special pointer inside of every member function called this. This is a pointer to the state of this object. Notice how I can use the member dereferencing operator, and I can access its members. I can also access the members directly. I can say count equals 10, or I can say this count equals 10.
A special note, just purely because this confused me for so long because I got slightly the wrong end of the stick. This, as it's used here on line 33, is an inventory.
Yes. Well, an inventory. Inventory. Oh, I hate you so much. An inventory pointer.
Yes, sorry, an inventory pointer. It isn't. What I'm getting at is it's not. It doesn't refer to the method that contains it correctly. It's not. It doesn't mean add product.
Yeah.
So I mean, how can you tell, like hierarchically, how can you tell what this is?
Well, this is always going to be.
It's always going to be a class or a.
It's always going to be a pointer to the class. It's going to be a const pointer to the class. Well, of type the class. It's going to be pointing to the instance of the object. So you'll notice that if I on add product, if I do something like this. And then down here, immediately before invoking add product, I do cout and run this. You'll notice that these will be the same. Address of new inventory is this address, FC10, and then address of this is FC10. It's the same address. It's the same bit of memory. Literally, the C++ compiler will turn every single method into a method or a function that looks like this, and it will add an additional parameter to it and invoke the method given that additional parameter. And that additional parameter will always be a pointer to the type, the containing type.
Cool.
Okay, so okay.
Accessibility.
Yeah, we can do that. Okay, so accessibility, we're only going to be talking here about public and private. Now, some people were mentioning protected earlier. Protected only comes into play once we start talking about inheritance, which we are not going to be talking about until next week. So we're going to be talking about public and private. What's public and private? Well, public and private are accessibility modifiers. And they behave the exact same way that you would expect them to in a language like C# or Java, although the syntax does look a little bit different. We are going to be talking about friend. Friend isn't an accessibility modifier, but it's something that is important in terms of accessibility.
Is that something you learned from the ponies?
No, there's a keyword called
Is
friend.
it magic? Is it magic?
Yes. Friendship is magic.
Sorry.
Oh, you got me thinking about the book again. I hate you so much. Okay, so accessibility. Every member within a class has an accessibility level. And the accessibility level is defined by the block that is it. Remember, the only difference between a class and a structure is that a class has a default accessibility of private, whereas a structure has a default accessibility of public. Meaning that if I wanted my inventory to behave like a structure, I could do this. Now, private accessibility, I'm going to put this in here. This is redundant, again, because classes have a default accessibility of private. But I'm going to put it in there just to be explicit. The private accessibility means that a particular field may only be accessed by the type itself and another particular use case that we'll be talking about in a second here. So private accessibility is all about encapsulation.
Privacy.
Well, yeah. It's all about not allowing people to reach in and modify your fields. Because really, when you think about it, fields are an implementation detail. When I say implementation detail, what I'm referring to is fields are the little bit of state that an object needs to carry around in order to perform its duties. There are not the duties of a type and the state it carries around to perform those duties are not tightly coupled, and they shouldn't be. If you have a type that is tightly coupled to the state that it carries around to perform its operations, you will run into issues as you try to modify the way in which your type works. A typical good object-oriented practice is going to be to allow the objects as much flexibility as they need to change given new requirements without causing issues to other bits of your program. Accessibility is all about locking people away from the state of your types. It's all about preventing people from accessing the state of your types, which will inherently give you so much more flexibility as you write your code. Now you might be wondering, so if I can't make field public, oh, by the way, when I have a underscore, this is my naming convention for private fields. Private fields I lead with an underscore, and then I follow with camel casing. So I just want to point that out. But anyway, back to my mocking voice. Well, if I'm going to make all my fields private, how am I going to access the data out of my type? Well, what you're going to do is you're going to create what are called accessors.
Special question for the C# people. That you should make.
What?
See if any of the C#. Well, there's kind of a gotcha on this for C# people. Not so much a gotcha, more of a, oh no, you're joking.
Oh yeah, how would you guys do this in C#?
To specify, how would you access these private fields from outside in C#?
How would I allow other people to know what the count of my inventory is? Well, C++ doesn't have properties. So what you have to do is create what are called accessors. And the term accessor is common in all languages that don't support properties, including Java. When you hear the word accessor, all that means is it's a public method that gets to know about private state. So for example, what I could do here is I could write a method here called int get count and have it return count. This would be a properly architected way to return the count of our inventory.
And what if you wanted to change the count?
Well, I would
Oh,
add
it's
a
because you
product.
picked count. It wouldn't. Yeah, exactly.
Well, I see what you mean. You wouldn't do this, but this actually does lead into my next question. Let's say we can
Give the
magically
product
set
a
the
name.
count.
Give the product a name. Just give it a name, and then you can do this without feeling bad.
Well, the product is struct. Or what? The inventory, give the inventory a name?
Do it so that we'll pick on something that isn't count.
All right, the inventory is going to have a location. So what I would do is I would have string get location, void set location. And I want to point out two very important things about this code. Three very important things about this code. First of all, this code is not very performant. And the reason it's not is we are copying entire strings around to pass forward and backwards our parameters. You certainly could use pointers, but that would make the syntax very awkward on the caller side. You would typically use references, but that introduces issues of mutability. Therefore, the way that you would generally see this code written would be something like that. But I just want to point this out in case people like go on the IRC and talk about the homework and they're like, oh, and then Mr. Charisma comes in and it's like, well, you should really do it like this. I'm just
Comic Sans.
yeah, I'm going to say this is how you should do it, but we're not going to be talking about const or references, so because that would introduce a lot of more discussion that we would have to do. The second const makes the method itself constant.
It's horrible syntax that we don't want to think about. It's really confusing.
Yeah. We would really want to do this, use const references to do what I'm describing here, but I want to point out we're not doing that because we haven't gone over that bit of syntax yet. So for now, this is perfectly acceptable.
Well, the thing is, because this relates back to what I was saying before. This, as it stands, you would only have to change, well, 2 words, I think, to make this look like old-fashioned C# properties.
Huh?
You've got a getter and you've got a setter.
Yeah. They're very similar.
But you're saying it's not performant, and
well, the reason it's not performant is because we're copying back a string forwards and backwards because we're copying them by value, which we wouldn't want to do. We want to copy them by reference. But we haven't talked about references yet. I just wanted to cover my bases in case someone was like, oh, you're not teaching C++, right? Anyway, so are there any performance differences between object-oriented programming style code and procedural code since it's all converted by the compiler anyway? Yes and no. It really depends on your code. I could quite very happily write horribly unperformant procedural code and incredibly performant object-oriented code. There are some considerations, though, as you move along that will possibly cause concern. For example, what I have right here where I'm passing a string by value after invoking a method. Now, I do want to point out, however, that these accessors potentially may be inlined by the compiler, meaning the compiler may very well take this code and literally copy and paste it to wherever it's invoked from. So don't worry about the additional method invocation. The performance characteristics of your code, though, are not coupled to the paradigm you're using. And again, just like how I could easily write really slow C++ code and incredibly fast C# code, just as you could write incredibly slow procedural code, incredibly fast object-oriented code. It doesn't matter. Is the underscore common because it looks ugly to me? The most common convention I see for local fields in C++ is the M underscore prefix, but I don't really like that very much. I use the underscore prefix for a few reasons. First of all, it groups together by private fields in IntelliSense. Or if you were using this, of course. So if you look at the member list, you see all of our private fields down at the bottom. It makes it really easy, in my eyes, to distinguish between private fields and local variables. Now, this actually becomes incredibly important when you have setters, or a constructor that takes in a parameter that's set to a field.
But Nelson, I really, really, really don't like them, and I want to call my field location without an underscore.
Well, if we take the underscore out, look what happens.
He whined.
Location equals location. Well, yeah.
Hello.
It'll compile. Basically, we're just
kidding.
assigning the parameter to itself.
Yeah.
So in this case, you would be forced, you would not be able to do this optionally, but you'd be forced to preface your field with this. And the fact is, I see the occasional use of qualifying your fields with this, sometimes and not others, to be so much more obnoxious than having an underscore that clearly delineates a member as a field. Then again, it is a preference thing. You'll see crazy styles all over everywhere. We talked about earlier how because C++ is such an old language, and it was derived from an even older language, how the actual naming conventions and formatting styles have there's just so many different kinds available. The one I will be using, though, is going to always be underscore for private fields.
Lovely.
Sorry.
Bless you.
Oh crap! I hit the pause button on the recording instead of the mute button on the webinar.
Oh, well, that's good. At least you didn't record that. Do you want to unpause?
Yeah. Okay, so how's everyone feeling?
Just shiny.
Shiny, Captain?
Oh, don't.
You've seen Firefly, right?
Yeah, that's why I really don't want your voice anywhere near that sentence. I'll just stick with her in the dress with the strawberries. Anywho.
Okay, so I guess we're going to be moving on. Okay, so private accessibility means that we can only access these members from within the type itself. We may not access these members from anywhere else. You certainly are more than welcome to make public fields. That is highly discouraged, however, and you shouldn't use it. Fields are an implementation detail and should be abstracted from the actual interface, as in the actual API. The way you interact with the class should be independent of the actual state that class carries around to performance operations. How's everybody feeling about private and public? Goog?
Yes, he's feeling goog. Somebody else is feeling good.
Okay, let's talk about friends. Just, if I wasn't sick, I'd be able to totally come out with a pony pun right now. Okay, what a friend is in C++. A friend is a way to let another class access the private and protected members of one class. In fact, friends are, by using friends, you can sort of kind of mimic the behavior of internal. So let's go ahead and talk about a friend class, or friend type.
What's internal?
I was saying that for the sake of the C# guys.
Yes, I know that. That's why I
You say
asked.
private fields can be accessed from the same type. Does that include other instances of the same class? Yes. Very important concept. I can't believe I missed it. Thanks for the question. If I had a method called bleh that took in an inventory, I can access the inventory dot or access count, for example, if I wanted to. You can access the private members of another instantiation of the same type. Okay, so I can't.
I read his question slightly differently, in that what if you have two inventories then? You can't read each other. How do you have two different?
What?
You say private fields can be accessed from the same type. Does that include other instances of the same class? I.e., if you've got another instance of inventory, do they share the fields?
No. They don't share the fields, but you can access them.
Yeah, I just wanted to clarify because that's what I thought he was asking. But
okay, so let's talk about friends. I can't think of a super awesome, great example at the moment off the top of my head. So I'll just go ahead.
I mean, for now,
Let's just go ahead and just give this out. Okay, let's say we have a class 1. Class 1 has a int bleh member on it, and it has a public int get bleh that returns bleh. Then let's say we have a class 2, and my class 2, I want to be able to access I want to be able to do cls1.bleh equals 20, and then cls1.getBleh cout. So this is what I want to do. I want to have class 2 able to access class 1's private fields. How do I do this? You make them friends. Now,
so is that more performant than the accessors, or is it
still be highly discouraged.
more better in other ways? I can't think of the word, but I mean, what's the benefit of doing this?
The benefit of doing this is most often what I tend to find is the ability to represent data structures. I think I really included the concept of friendship for completeness in this discussion about accessibility, at least as far as we could go with it, because obviously we can't talk about inheritance yet. But I haven't used it all that often. I have used it for some cases where I really wanted to pass around, I really publicly wanted to pass around a type to other things. But I wanted that type to be able to reach into another type to modify it internally. That problem can be mitigated by proper use of interfaces as well. But this is just a potential feature for people to use. But remember, by doing this, you're truly breaking encapsulation.
I was going to say, because somebody brought it up in BuzzNet, is class 1 class 2's friend now as well?
No, it's not bidirectional.
Cool.
So yeah, I mean that's really all there is. I do really want to point out, friend class 2. The fact that I have a class right there is not a mistake. Remember, the C++ compiler looks at things lines 1 by 1 by 1. Meaning, until it hits class 2, it doesn't know what a class 2 is. By doing friend class 2, I am forward declaring the existence of class 2. You may forward declare the existence of classes in C++, but you may only use those to represent pointers or friends. You can't use them to do anything more complicated than that because the compiler doesn't know yet what it is. You're just promising the existence of a class at some point. So the fact that I have friend class 2 is because class 2 hasn't been defined yet and I must forward declare it. Okay, so how's everybody good? How's everybody with accessibility and friends? Because we're going to move on to header files and CPP files, and that's really going to be about it.
Would friend fall into class of things where certainly for now, and we've said this about a couple of things before, it's more likely something you'll find in other people's code that you need to be aware of than something you'll be wanting desperately to
Yeah.
get the, yeah.
I would encourage people to stay away from friends and try to express themselves differently. But they can be useful, I suppose.
Cool.
Okay, so how's everybody feeling so far? Okay.
Cool.
So let's talk about header and CPP files. It's really straightforward. I'm going to go ahead and create a product.cpp or product.h. I want my resharper back. Even in C++, the resharper control dot shortcut still works.
That makes sense.
Yeah.
It's yeah. Because it's an IDE thing rather than a... We should totally make the final project for the class be to write a C# IDE that runs on Android. I want one. You having fun?
Alrighty. This code is problematic. Anybody tell me why this code will compile and run, but will be very problematic if something. I'm not going to say what that something is because it'll totally give it away.
So you think there's a problem with this code, and that problem is problematic,
Yes.
and that there's a certain problem that you could introduce that would probably be problematic.
Yep.
Properly problematic, or just partially?
No, it'll be pretty problematic. Okay, so let's go ahead and hit F5. Oh, hold on. I didn't expect this. Oh.
Okay, assuming Nelson had written this properly, what's wrong with it?
Okay, notice how when I run it... Notice how when I run it, it works the way we would expect it to. But watch this. You guys want to see a magic trick?
Most definitely.
Oh, come on.
Well done. A proper magic trick.
On break. Please don't tell me you're optimizing that out.
I'm optimizing that out. Because I am, as ever, sending out optimistic vibes. I said because I am, as ever, sending out very optimistic vibes, being the naturally bright-side-looking person that I am. Have you broken it yet? Have you managed to fix breaking it yet?
No, not yet. Hold on, sneeze. Okay, and we're back. So what we need to
actually,
What?
we discussed friend classes, but not friend methods.
We're not talking about friend methods.
Good.
That's a
I didn't want to in the first place. Somebody brought it up. I wasn't expecting you to unpause just then. So essentially you tried to break this and it won't.
No, I completely forgot about something. But there still is a problem with this code, at least conceptually. The first problem is that...
Well, first off, what did you do to fix it?
Well, I didn't do anything to fix it. It never broke. I was trying to get the linker to blow up, but I forgot that the C++ compiler mangled the names differently under certain circumstances. But what's going on here, though, is this is typically not how you would write a class in C++. The header file shouldn't contain the implementation. There's a few reasons why you shouldn't. The biggest one is being able to, or the size of your header files is probably the biggest one, and sort of the organization of them. The very typical practice within C++ is always going to be to declare your classes and then to implement them in a different file. Another very important aspect to this, and one of the reasons that you should do this, is that because C++ doesn't kind of identify your entire program at once, doesn't parse your entire program and allow circular dependencies or forward, or not forward declarations, but it doesn't backtrack over the compilation stages like other languages. You won't be able to, for example, do things that you would want to be able to do within your code. And yeah, pretty much. And other issues that you have with header files versus CPP files is that first of all, you'll notice how we were using the namespace qualifier std right here. The reason I did that instead of importing the std namespace is typically you don't want to do that in a header file because that would inadvertently import that same namespace into another CPP file. So to break this apart, there's a bit of syntax that you need to be very aware of, and you should always break out your header files into both header files and CPP files when talking about classes. So if I go ahead and add in a inventory.cpp file, the way in which I would implement this in a CPP file would be like this. I would first include our inventory.h file, and then I would write the definitions of all the methods in the CPP file.
So if you didn't know that this was bad to do it the way that you already done it, what would actually need to go in the CPP file? Anything at all? Really other than the include?
Nothing. What should go in the CPP file are the methods of the type.
Yeah.
So you'll notice how I'm moving.
It struck me as you did the include. I always think of that as being like basically a condensed. It just points at all that chunk of code. I read it as being that chunk of code is there from the H file, and I just suddenly thought, well, essentially, you've got everything. It would be. Oh, words. It's getting late. Don't you wish you had properties? Yeah. Auto properties.
I like properties. Well, I sometimes like properties. I like automatic properties. Alrighty. So this is how you would typically split a class from a header file to a CPP file. There are quite a few cool things you can do by splitting them, not just the convention and how you really should do this, not just for the potential growth in file size during compilation, but also so that you can represent a certain level of circular dependency. In that, my CPP file on the left at inventory.cpp is free to include other header files that may also depend on inventory.cpp. So therefore, I'm allowed to express some level of circular dependency when appropriate. It's not typically appropriate, but it may be, where I want some logic in inventory.cpp that I can't pound include into inventory.h because that would cause the preprocessor to go crazy. But ultimately, this is one of those things that you just do. And this is how you do it. Are there any questions about doing this?
Well, there's one. It's there.
I've been told that's okay to keep it in the header file only if it's one line of code. Would you agree? I would, but I didn't want to discuss that because I was trying to sort of establish a sort of precedent. The fact is, if you only have one line of code, for example, get or set, by putting in the H file, you open up the opportunity for the compiler to inline that function invocation. But it's more important to learn the concept and get used to separating it out than worry about the exceptions to the rule. However, I typically would put single-line method invocations or methods into the H file. So what does the namespace or the resolution operator do exactly? Yes,
it's an operator, not an operand.
Yeah, it's an operator, and what it does is it accesses things. Literally, that's all. The colon operator is used in place of the dot operator. In the case of C#, basically you'll notice that you use the colon operator in terms of namespaces. So you'll notice to grab the string type, so you'll notice on line 20 over here on the inventory.h, to yank the string type out of the std namespace, I use that resolution operator to identify it. In much the same way, on lines 5, 12, 18, 23, 28, and 33, we're reaching into the inventory type. We're qualifying our member definition by providing the type that we're defining the member for. And we do so via this operator. This operator is also how you access static data and static methods from within a class. So it truly is something that you would normally think of as a dot in C#, but in C++ as a colon. Do you create separate H files and CPP files for every class? Again, it's one of those rule things. Almost always I do, but there's always exceptions. Sometimes I might even create a class within a CPP file that's only used privately within the CPP file, not accessible elsewhere. The
one primary one that you won't create an H file for is main.cpp.
Yeah.
Or equivalent, because generally speaking that will do the reference. It will reference other things rather than vice versa.
Right.
And this ties into actually what Wolf Knightley's just asked as well, which is I don't really get why you need a header here at all.
Well, the reason you need a header is the same reason you would put your methods and structures into a header. The header will make it available on a larger application when we have more than one source code files. The header makes it possible for us to import in a type from another file. So now we can have as many CPP files as we want, all importing the inventory.h file and using the functionality defined in it. It's not only just an organizational tool, but it's a reusability tool as well. Because, again, if we have additional bits of CPP files elsewhere within our application, we now have access to the inventory functionality. It provides us a level of reusability. Now, I know you might be used to C#, where you don't need to include anything in. At the very least in C#, you need to import the namespace, but...
I was going to say, yeah, well, it's just like, you can think of it just like your usings at the top of your C# files.
Yeah.
You need to be using inventory.h, essentially, but it's called include. Conceptually, it's doing the same job. It's making available what's inside it.
Yep, this definition of inventory.
This is partly ties in with why before I knew anything properly about C++, my sort of thumbnail sketch of what these might do, just from looking at how they were used in C++ files, led me to think them in much the same, or certainly they share a lot with C Sharp's interfaces in terms of just structuring your code.
Yeah.
And provide, if you're in it provides the same sort of guarantees as well. If it's mentioned in product.h, it's gettable. But anyway, sorry, carry on.
Else you can't use your class. You do not need to use H files and CPP files and stuff to use classes. But you do if you want to make this class available to other files. Now again, remember in C#, I can stick 2,000 classes into a single file. And then I can jump right into another file and I can just use them like they're all right there. C++ doesn't work like that. C++, you really need to be explicit about how the definitions of your types get imported during the phase of compilation. And remember, compilation only, the stage of compilation only cares about CPP files, and it completely ignores H files. H files are a way for you to reuse a definition of something. It's you're saying, this is what an inventory is, these are the methods on it. Now, those methods will be implemented elsewhere, of course, but by having that common file or that common definition, you've made it possible to use that type throughout your application. Yeah, if you didn't have the H file, you wouldn't be able to use another CPP files. Which isn't technically true, because in other CPP files, you could just simply take all this, copy and paste it every time you want to use it. But that'd be
you couldn't
really obnoxious.
You couldn't just comment line 4 of main.
No, I couldn't do. This would break because you'll notice error identifier inventory is undefined. Okay, so how's everyone feeling? Is everybody super stoked on classes?
They're like totally red, dude.
Are there any questions?
What's the capital of Peru? Lima.
It's capital Washington. I know that one.
W. Is it? I assume it's Seattle, seeing as no one's heard of any other
That's
city in
hilarious.
Washington.
That's hilarious. That's the number one misconception about Washington to people who don't live here. It's actually Olympia.
Oh no, I'm sure the number one misconception is that it's the same place as Washington D.C.
Oh no, yeah, that is the biggest misconception actually. The second biggest is the everybody thinks Seattle's a capital. It's Olympia actually. Which I think
Olympia.
Yeah, we have a city named
Wow,
Olympia.
that's on the tube. Anyway, we seem to be straying somewhat from the point. There are a few questions of.
Yeah, well, that's how Gav thought of them too. I mean, it's a good conception to have. It's a similar concept, and it's not exactly the same, obviously. In fact, there are interfaces in C++. Well, there aren't technically interfaces in C++, but you can represent them in C++.
The contract aspect of it, though.
Yeah, so don't try not to get that confused, but just in the context of H files and CPP files, there are some similarities. Okay, I'm going to go ahead and pause the video.
Is that it?
And we're back. So no questions came in, so let's go ahead and talk about homework. Homework is going to be very, very straightforward. You guys wrote a linked list last week. I want to see a linked list written in terms of classes using proper encapsulation. So I want a product linked list called inventory, if you wish, or product, or an integer or a double linked list, and written in terms of classes. So you'll need at least two classes, a node, and a linked list.
Do you want to type out your text file for your, so that then the video definitely matches what you post.
All right, so
Given we haven't had classes yet, presumably you mean functions, not methods on there.
yeah, I really want to see people who, because this is similar to last week's homework, I want to see people copying and pasting their own code if they're still sort of unclear on the linked list implementation. Having the experience of retyping it out is very beneficial for this sort of thing. As far as friends,
in answer to a question, no, I'd rather people didn't.
Yeah, yeah. Should no still be a struct? If you really want it to, although you could make it a class.
It is kind of, it's a sort of, it's analog, not digital, that whole struct class thing. Yes?
Yeah.
It's where you make the cutoff and say, right, this is going to be a class as opposed to a struct. Just give them some guidelines.
Well, I really like seeing the word class, to be honest. The fact is, there's very little difference between classes and structures in C++. The word class, though, implies an object-oriented approach. The word struct implies a procedural approach. Unrelated to today's class, did you go over null pointers? I'm fiddling with SDL and I see them being used, but if I figure if you and a null pointer you crash hard, maybe you talked about. I thought I talked about null pointers. A null pointer is a pointer set to the value of null, and therefore points to nothing. It's a common convention.
Yeah, we did talk about that. I'm sure we did.
Pretty sure we did.
Because I remember you mentioned it being capitalized.
Yeah.
And I remember a discussion over that at some point in one of last week's classes. Open office things.
I don't know when we'll have an open office hours. I don't know. It probably depends on how I'm feeling. And
but also what time?
Maybe I'm thinking maybe
because there's going to be a lot to.
Yeah, I'm thinking maybe Thursday on this one.
But we've got C#.
Yeah, but we can do early Thursday. I don't have Aaron on Thursday.
Yeah.
Okay, so I'm going to go ahead and stop the video. Clocked in at 1 hour and 43 minutes. So, yeah.
Cool. All right then. Well, enjoy the homework, and we'll see you all at the next thrilling installment.
See ya.